This is a quick demonstration of the Sync and Merge utility added here under Utilities, Sync and Merge Time Series. The purpose of this, this is a user interface. Previously I made a demo of the scripting mode version of this. So here we're going to start with the master file path. Let's go in the input directory. We have a BDF file. So this is an EEG file recorded with Active2. Associated file path. So this is the one we want to sync and merge with the EEG. Currently, this supports the CRS live track. So I'm going to select the live track file, and now I'm going to make the output. This will be the merged file. It'll be a BDF file. Let me call it active2 _ live track. And let's just say then, okay, so we have a couple of quality controls. So we'll require at least 20 common events between the two files. The events are used for synchronizing. We'll actually end up using a lot more than 20, but that's just a minimum. And we'll require that the maximum matching error would be 4 milliseconds. So we won't, if there's a matching error, RMS matching error greater than 4 milliseconds, we'll not accept that. Okay. So it read the events for the EEG file. Now it's reading the events for the live track. It takes a little bit longer because it's an ASCII file with timestamps. Okay, now it's creating a BDF file which is just the live track data, but it will be aligned to the EEG data. So this will be a BDF file of the live track data that's aligned but not yet merged with the EEG file. Okay, that's writing the BDF file. Now we're going to merge the data and create another BDF file that has both the original EEG and the live track data. Okay, that's it. This is utility, so it doesn't automatically create a workspace. Let me show you here where the results went. Okay, so we started, I unzipped this file here to start with, and created this file as the main output, active2 _ live track BDF. You can see that's the biggest file. The alignment results are here in this text file. We went over that in detail in the scripting mode version of this, so it's the same thing. In the input folder now, we started with just these three files up here, and now we also have some additional files. Okay, let's just quickly make a workspace. let's add the BDF merged file. Let's double click on that. Let's make a probe, but not add the average brain resource. Okay, so we can see here now we have all these channels in blue which are matched to the probe. EXG1 I do believe is the left mastoid. EXG2 I do believe is the right mastoid. Some of these others are there. EXG7 is an EKG channel. Then these are live track channels, including the trigger channel. Let's say OK. Okay, so there's EEG channels, and if we go down here, not using the same color scheme as before. This is the default color scheme for channels that are pass-through channels, so they don't have matching sensors in the probe. But here you see as before. Let's just quickly put in, let's say, a digital reference, average mastoid. Let's add a digital IIR just to get rid of the trends in every, let's say, get rid of the trends in everything except the trigger channel. Let's put a high pass of 0.2. Okay, this is very similar to what we looked at before in more detail. From what we saw previously, we expect these periods of time to correspond to blinks. So let's move up here and see, indeed, we see a blink there. We see blinks there. These are frontal channels. Let's just quickly map it. Since we have our probe, indeed we see a blink frontal topography. Okay, so we already went over this in detail in the other video in the scripting mode version to show that the events are indeed aligned, but this is a quick way to show that the live track, when it is when the live track is not tracking the eyes during an eye blink, indeed there is a blink right there. Okay, we'll stop there.